the relative masses of atoms and molecules, Cambridge iGCSE Chemistry. So Cambridge requires knowledge of relative atomic mass, which I have also covered in the class Atomic Structure and Isotopes, molecular and formula mass, calculation of percentage composition by mass, and calculation of reacting masses by simple proportion. Relative atomic mass, capital A subscript R, is an average mass of the isotopes of an element compared to the mass of 1/12 of the carbon-12 atom. So 1/12 times the mass of the carbon-12 has a relative mass of 1. Therefore, relative atomic mass, as it's a comparison between masses, has no units. The number, the relative atomic mass, is calculated for each element by averaging isotopic masses, taking into account the percentage abundance of each isotope. So if we take, for example, chlorine, 2 isotopes, chlorine 35 and chlorine 37, abundance is 75% of all chlorines are chlorine 35 and 25% are chlorine 37. We do 35 times 75 plus 37 times 25 divided by the number of items, which is 100, comes to 35.5. So on average, the mass of a chlorine atom is 35.5 times the mass of a 1/12 of the carbon-12 atom. So if you'd like to try this example, calculate the relative atomic mass for neon. You've got 2 isotopes, neon 20 and neon 22, relative abundance 90% and 10%. Calculate the relative atomic mass. Stop the class, restart when you are ready. Okay, so 20 times 90, 22 plus 22 times 10, divided by the numbers of items, which is 100, 20.2 is the relative atomic mass of neon. So let's now talk about relative molecular mass and formula mass. So the sum of the relative atomic masses of the elements in a molecular formula is called the relative molecular mass, and it has the symbol capital M subscript R. Let's take an example, the relative molecular mass of carbon dioxide. We've got 1 carbon, we've got 2 oxygens in the formula. From the periodic table, we get the relative atomic mass of carbon at 12 and the relative atomic mass of oxygen at 16. So 1 times 12 plus 2 times 16 comes to 44. We can apply this, so 44 is the relative molecular mass of carbon dioxide. We can apply the same idea to ionic compounds, but ionic compounds don't form molecules, so we have to be careful about the name. We've got a specific name, the relative formula mass. So the relative formula mass of calcium chloride, CaCl2, 1 times calcium, 2 times chlorine, 1 times 40 from the periodic table, 2 times 35.5 from the periodic table, comes to 111. The relative formula mass of calcium chloride is 111. So here are some simple problems which you may wish to complete. Calculate the relative molecular mass or relative formula mass of the following formulas. Use the periodic table to obtain the relative atomic masses for sodium and oxygen, etc. Work out the relative formula masses or relative molecular masses. Come back to check against my answers when you are ready. Okay, so sodium oxide, 2 times 23 plus 16 comes to 62. 4 carbons and 10 hydrogens comes to 58. 2 hydrogens, 1 sulfur, 4 oxygens, each at 16, 98. A little bit careful here, 40 for calcium, but everything inside the bracket is multiplied by 2. So Inside the bracket is 16 for oxygen and 1 for hydrogen. We have to multiply what's inside the bracket by 2. So 40 plus 34 comes to 74. Similarly, 40 for calcium again, but inside the bracket we have 1 nitrogen and 3 oxygens. 1 nitrogen and 3 oxygens. We need to multiply everything inside the bracket by 2. So 2 times everything inside the bracket comes to 164. If you didn't get that right, do it again. Finally, waters of crystallization. Copper sulfate, 1 copper, 1 sulfur, 4 oxygens. Then waters of crystallization is shown by dot 5 H2O, so it's 5 sets of water. So 64 for copper, 32 for sulfur, oxygen times 4. Then 5 times water, which is hydrogen twice and oxygen, comes to 249. Again, if you didn't get that right, go through it again till you are certain. Calculating percentage composition by mass. Percentage composition by mass is calculated by dividing the total relative atomic mass for a particular component of a formula by the formula mass as in total and multiplying by 100. Let's see how that applies. Calculate the percentage by mass of calcium in slaked lime CaOH twice. So our particular component in this case is the calcium, Ca. So we want the mass in the formula due to calcium over the relative molecular mass or relative formula mass times 100 to turn it into a percentage. 40 for calcium divided by 74 for calcium hydroxide, that's slaked lime, times 100 comes to 54%. So here are 3 problems centering on the percentage of sodium within 3 compounds: sodium bromide, sodium oxide, and sodium carbonate. Show in the first example that the percentage of sodium in sodium bromide is 22.3% by mass. For sodium oxide, calculate the percentage composition by mass for sodium, and for sodium carbonate the same. So stop the class, show how 22.3 is achieved and what are the percentage compositions in the other 2 cases. Stop and restart when you have your answers. Okay, so sodium is 23, bromine is 80. The relative formula mass, therefore, sodium bromide 103. 23, which is, we've got 1 sodium, so 23 divided by the formula mass 103 comes to 22.3%. The answer to the percentage composition in sodium oxide is 74.2. We've got 2 sodiums, so 2 times 23 plus 16 comes to 62. The percentage of sodium is 46, 2 times 23 out of 62, times 100 comes to 74.2. For sodium carbonate, the answer is 43.4%. 46, we've got 2 sodiums, each at 23. So the mass in the formula due to sodium is 2 times 23, 46, divided by the formula mass, which is 106, comes to 43.4%. As the balancing of a chemical equation is fixed, it follows that the ratio of formula masses in the balanced equation are also fixed. So if we take iron and sulfur reacting to make iron sulfide, the formula mass of iron is 56, of sulfur 32, of iron sulfide 88. So the ratio of iron to iron sulfide is 56 to 88. The ratio of sulfur to iron sulfide is 32 to 88. That will always be the case. So we can use that simple proportion to calculate reacting masses. So let's imagine we've got 28 grams of iron. What will be the mass of iron sulfide produced? Intuitively, one can usually see that 56 makes 88, so 28 grams would make 44. But what was the maths behind that? Well, we did 28 divided by 56 times 88. So the proportion 56 to 88 means that if we divide 28 by 56 and then multiply it by 88, we will come to the answer. Okay, so this relationship, 28 to 56, must equal 44 to 88. What would be the mass of iron sulfide if we reacted 100 grams? What is the mass of iron sulfide that would be produced on complete reaction? Okay, so the answer is 157 grams. How is that achieved? 100 divided by 56 times 88. 100, that's the mass, divided by 56 times 88. Okay, so it's always 56 to 88. What if we have 2 grams of iron? What mass of iron sulfide? Stop the lesson and work that out. Okay, well the answer is 3.14 grams. 2 divided by 56 times 88. So we can use the simple proportions 56 to 88 to calculate or predict reacting masses on complete reaction.